Our next topic is to discuss working with the normal curve along with or in conjunction with binomial experiments. Up until now, we've been discussing working with the normal curve where the data set is essentially a measurement, a length, a width, a number of objects, values where we're computing means and standard deviations. But now we take it and we extend it to the notion of a binomial experiment. Remember, a binomial experiment is a success-fail. Right? It's a success-fail where we sample a certain number of objects and then determine what proportion of them satisfy a certain condition. One of them is called success. One of them is S-U-C-C-E-S-S. One of these is called success, one of them is called failure. Recall that P is the symbol we use to represent the probability, or we can also think of it as the proportion. The probability or the proportion of success. And remember, this is for the population. So if a population has, let's say 75% of a population has a certain quality, then, and if we define that quality as success, then in that case P would be 0.75. It's the probability of success or the proportion of the population that have that quality that fall into the success category. And then similarly, Q is the probability or the proportion of failure of the population. And recall there is a relationship that P plus Q must total 1, or the way we typically use this is the statement of the property, but the way this is most typically used is here. Usually for our problems, the value of P will be given, the value of Q will typically not be explicitly given. But the value of Q is going to be needed for some of our formulas. And so if P is given and Q is not, this is the rule that allows you to compute Q. Q does not need to be given. If the value of P is known, then Q is equal to 1 minus P. Remember, P is the probability of success or the proportion of success, and then P and Q must add to 1, so Q is 1 minus P. Now, there's another piece of information. How was P going to be established? The value of P, one of two things. It's either going to be given. So one possibility is that the proportion of success or the probability of success will simply be given in the problem. Very often it's stated as a percent. So if it says, if you're given 62% of a population, you would write that as 0.62. Very often it's given as a percent, but we always write and compute with proportion, not percent. The other way that P could be known is this. You might be given N is the number of trials, and X is the number of successes. And in that scenario, P is given by X divided by N. Typically, for most of our work, P will be explicitly given. In some scenarios, however, P is not explicitly given. What you are given is the number of trials, N, and X, the number of successes. And then in that scenario, P is equal to X over N, and then as always, Q is given by 1 minus P. So you should be able to find these values and use them in the formulas we're going to be requiring. Now, the formulas we'll be working with, we're going to cut to the chase scene. I'm going to simply give you this formula out of the blue sky. so we'll accept this without proof and without development. But when dealing with a binomial setting and the normal curve to use to find those probabilities, this is the z-score we will use. It's written as p hat, we'll talk about that in just a minute, minus p divided by the square root of p times q over n. And this entire fraction is inside this radical, not just the numerator, it's the entire fraction. Okay, so in this expression, the value of p is what we've discussed. The value of q is what we've discussed. This is multiply. The value of n is the number of trials, or the sample size. Number of trials and the sample size are the same thing. But now we need to know, what is this notion of p with this little, the technical word is a caret, but typically what you call this, you talk about what's called p hat. It's not fat, it's p hat. Anyone who knows what you're talking about knows what this means. P hat is the proportion of success. It's the probability of success of the sample. P is the probability of success of the population. All right? It's rather like, up until now, we've been saying the population mean is mu and the sample mean is x bar. Well, here, the population mean is lowercase p. The sample mean, we don't use p bar. We don't use this symbol to represent the sample proportion, because it turns out that represents something else later on. What we use to represent the sample proportion is p hat. It's pronounced p hat. And again, anyone who knows what you're doing knows what this represents. This is standard. Any course you'll go to will have that symbol. And so the z-score is formed by p hat minus p divided by the square root of p times q all over n. So this is the z-score we're going to use. And in the next video, I'll go through several examples of problems involving this notion. And you'll get used to it. It's not that big of an issue. Remember, all these formulas you need will be given to you. You don't need to memorize the formulas. So the next video has several examples of this problem worked out.